I want to tie the graphs of the y equals x to the third power to the graphs you're more familiar with, which is y equals x squared. The shape is determined in part by if the number in front of the x to the third is positive or negative. When we had those parabolas, the x to the second powers, when the number in front of x squared was positive, it was smiling, the parabola, and if there was a negative in front of the x squared, it was frowning. The graph of a cubic, it kind of looks like a slide, whoop, like that. And so sometimes it's going up and sometimes it's going down. When you read a book, you read from left to right. The same thing when you look at a graph, you want to look at the graph from left to right. So if you move your eyes from left to right, notice that your eyes go up. And so the number in front of to the third power is going to have to be positive. And here, if I look at this graph and I move it, I look from left to right, my eyes go down. And so I know that the number in front of x to the third power is going to be negative. So that's just a little bit of background information. The ones that we're going to look at today have not been shifted right, left, up, or down. And the reason I know that is because we don't see any addition or subtraction. When we had our parabolas x squared, that vertex was going to be located at 0, 0 if we didn't see any addition or subtraction. And the same thing is true with these cubics, is the important point known as the point of inflection is going to be located at 0, 0 if you don't see any addition or subtraction. So the first thing you want to do for these particular ones is plot a point at 0, 0 and know that there's your point of inflection. Now, a point of inflection is where the graph changes concavity. This right here, like cup up, frown down, this is concave up, whereas this section is concave down. So if you look at this green one, see how to the left of that blue point, it's on a section of concave down, and then to the right of that blue point, we're on a concave up, and then that one, this starts off being concave up and then changes to concave down. So that important point where that concavity changes is called a point of inflection. And one more time, we know for sure when we don't see addition and subtraction in our x to the third power equation, that point of inflection is going to be at 0, 0. So let's use that to graph this equation. I'm going to start off here immediately because I know that this is an x to the third power and I don't see any addition or subtraction. I'm going to immediately plot a point at 0, 0. Okay, now I need a couple more points on our slide, for a lack of a better word. And just a little background one more time is that because the number in front is negative 3/2, since it's negative, we know our eyes are going to go downhill. So the graph is going to look like this eventually. So it's just kind of nice to know up front. So let's go ahead and substitute a couple of numbers close to 0. I'm just going to select 1. So if I substitute in 1, I have my original equation. I'm going to replace the x in that with 1. And then 1 times 1 times 1 is 1, exponents first. And then 1 multiplied by negative 3/2 is negative 3/2. So when I substituted 1, I got out negative 3/2, so I'm ready to plot a point. So write 1 down 3/2, which is down 1 1/2. It's a little bit like the ones we were talking about, buy one, get one free with the parabolas. There's a line of symmetry, but instead of being a U shape, it's a slide. So watch this part kind of carefully here. If I know the slide in general is going downhill, if this was right 1, down 1 1/2, then the other point would be back 1, up 1 1/2, and I get an extra point. Okay, so then your homework assignments are asking you to plot 2 points on either side of the point of inflection. So I'm going to substitute one more number, x equals 2. Going into my original equation here, I'm going to replace the x with 2. Exponents first. 2 times 2 times 2 is 8. Remember, when you're multiplying by a fraction, you are really dividing by the denominator and multiplying by the numerator. So 8 divided by 2 is 4, and 4 multiplied by 3 is 12. It's a negative number times a positive number, so this is negative 12. I substituted in 2 and I got out negative 12, so I'm ready to plot my point. So I'm going to come over here and go right 2, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I'm almost off my graph there. Okay, then using that symmetry, if I went right 2, down 12, then I should be able to go back 2, up 12. So 2, 4, 6, 8, 10, 12. Ooh, I got off there a little bit. Am I okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I think I'm good. All right, so now that I have these points, I can sketch in the curve, and I probably will not be doing a very beautiful job of this, but let's try. So I'm coming down, boom, boom. Okay, so there's my cubic graph. Okay, so